Assalamualaikum. Today I will be presenting about my final year project, which is titled The Characterization of Car Bumper using empty palm fruit bunch. Before I continue with my presentation, I would like to introduce myself. My name is Muhammad Izzudin bin AZHAR. I am from BNG, which is Mechanical Engineering Technology, majoring in Automotive. Nowadays, oil palm industry has grown large and it also disposes so many biomass waste. As we know, the excess biomass waste is a renewable source of fiber that can be used as a possible reinforcing material in a polymer composite for eco-friendly car bumper. The study is to determine the mixture composition between the empty palm fruit bunch (EPFB) and the polyurethane resin (PU). This study also aimed to determine the mechanical and physical properties on 5 different ratios of samples. The polyurethane composite will be tested for its mechanical properties with the tensile test, bending test, and sound absorption test. For its physical properties, the 5 different ratios of samples will be tested with optical microscopy test and also density and porosity test. From the mechanical and physical testing that have been done on the 5 different ratios of samples, we can conclude that the most ideal composition mixture between EPFB and polyurethane is 0.8 ratio of EPFB to the 4:1 ratio of polyurethane resin. The result that have been obtained from tensile stress is 3.92 megapascals, and from the bending test is 10.199 megapascal, and also from the sound absorption test is 6900 Hz. For its physical properties, the density for the ratio 0.8 of EPFB is 0.22 gram per centimeter cube and only obtain 1% of porosity. For the optical microscopy test, the structure of for ratio 0.8 of EPFB is the most visible and has strong composite bonding between the PU and EPFB fiber. For recommendations, more variety of ratio might demonstrate more result of the mechanical and physical properties for the samples. Emerging global consciousness and community involvement, recent environmental regulation and unsustainable consumption of fuel have contributed to the discussion about the use of environmental friendly products. Composite materials such as modern car bumper are specifically produced and redesigned with the intention of developing and modifying conventional products and also implementing new products in a durable and sensible way. The empty palm fruit bunch (EPFB) is a promising natural material to be examined. Recent studies have investigated the reinforced polymer composite (EPFB), which has been shown to produce even better characteristics. This research is conducted to compare the characteristics of natural fiber and synthetic fiber. The study will also demonstrate the advantages of using empty palm fruit bunch extracted fiber compared to fiberglass as a car bumpers in the environmental, cost, health and production aspect. For the literature review, the greatest advantage of using natural fiber is cost effectiveness, low coefficient of friction, good thermal and dimensional stability. Next is empty palm fruit bunch is a high value resource that can be used for the benefit of the palm oil industry. These natural fibers are commonly used with matrices to enhance their specific tensile strength, flexural strength, durability and also break elongation. Next is excellent abrasion resistance, wear resistant, low coefficient of friction, and high tensile force, and strong non-polar liquid resistance are some of the advantages of thermoplastic polyurethane. Due to the advantages, polyurethane is widely used in textiles, automobiles, medical and also transportation industry. For the methodology, polyurethane Shaw A19 was chosen to be the polymer composite material to be combined with the empty palm fruit bunch. The empty palm fruit bunch was chopped to the fine pieces to be mixed with the resins. The mixture was divided into 5 different ratios, which is 0.2, 0.4, 0.6, 0.8 and 1.0 ratio of the empty palm fruit bunch to the 4:1 ratio of polyurethane resin. 5 different ratio will be left to cure for 48 hours. The 5 different ratio of sample will be cut into smaller pieces to fit into the tensile strength testing machine, bending strength testing machine and also sound absorption test machine. For its physical properties, which is for the optical macroscopic test and also density and porosity test, the sample was cut into a square shape. So this is the result that have been obtained from the mechanical and physical testing that have been done on the 5 different ratios of the samples. For the first graph, this is a combined graph from for the bending test and tensile test. From the graph, you can see that the orange line is the bending strength result that have been obtained from the test, and the blue line is the tensile test result. For the bending strength, you can see that the ratio 1.0 of Epfb yield the highest bending strength at the 10.983 megapascal, and followed by the ratio of 0.8 of Epfb with 10.199 megapascal. For tensile test, we can see that the most highest tensile strength is yielded by the ratio 0.8 of Epfb with 3.92 megapascal, and followed by the ratio of 0.6 of Epfb with the 2.79 megapascal. For sound absorption test, the sample that can absorb most sound at high frequency is the sample with the ratio 0.8 of Epfb with the 5300 Hz of the sound absorption coefficient, and followed by the 1.0 ratio of the Epfb. For its physical properties, the most lightweight of sample is obtained at the ratio 0.6 of Epfb at the 0.164 gram per centimeter cube of density for the density test. For the porosity test, the least porosity percentage is obtained at the ratio 0.8 of Epfb with 1% of porosity. For the optical microscopy test, the structure of for ratio 0.8 of Epfb is the most visible and has strong composite bonding between the PU and Epfb fiber. For the conclusion, the objective of the experiment were achieved. The ideal composition mixture between Epfb and polyurethane resin PU have been determined, which is 0.8 the ratio of Epfb to the 4:1 ratio of the polyurethane. The physical and mechanical properties of the sample were measured. That's all from me. Thank you for your time.